All right, I'm back. I just saw myself in the camera, and I think some of the gestures I showed you in my last lecture probably didn't show up very well. Hopefully you got the point. So, intelligence testing. Okay, it's really important before I start talking about intelligence that I'm going to tell you that I'm going to follow the order that psychology has followed with regard to the topic of intelligence. Prior to officially agreeing on what intelligence is, we went right to testing it. So we're going to follow sort of the path that psychologists have taken. Our textbook does it in a little bit different order. I'm going to do it in the way that psychology has done it. So intelligence testing, we went right to testing. All right. So the first person who's attributed with having created a test that you might recognize as a test that's measuring cognitive abilities was Alfred Binet. He was hired by the French government to develop a test that would predict children's success in school. The goal was to figure out whether a child was actually ready to start school, regardless of their age. You know, here in the U.S., we have a very age-based entrance into elementary school. In France at the time, they were thinking, maybe we should worry more about whether they're cognitively prepared rather than how old they are, because people develop at different rates, right? The key thing that Binet thought theoretically was that intelligence was due to experience. It was not a function of genes or some kind of innate and immutable characteristic. He thought everybody has the same potential and that everybody could be brought up to the same level if they were given similar experiences and enough time to develop. He introduced the concept of mental age, and that's a really important concept that we continue to use to this day. I think you could tell from the picture that this is not a recent guy. He was doing this research for the French government in the 1920s. Oh, we're almost to the 2020s at this point. I better be careful. I mean, 100 years ago, he was doing this research on children, and he came up with the idea of mental age. So to establish the score that you would expect on his test for different age groups, he had different groups of children, 4-year-olds, 5-year-olds, 6-year-olds, and stuff like that, take his test. And the average score that those groups got, so the average score for the 4-year-olds, the average score for the 5-year-olds, and so on, became the score that we would expect from a person who had the mental age of a 4-year-old, a 5-year-old, a 6-year-old, and so on. So he was mostly interested in those younger age groups because he was trying to figure out if they were ready for school. And kids were starting school at 5, 6, 7, something like that at that time. So he had a bunch of children take the test, and their average score served as the mental age that the subsequent children who were actually being tested would be held up against. So if you took the test at the age of 5, but you scored like the average 4-year-old, he'd say that you have the mental age of a 4-year-old. Now, he would not say that like because there's something wrong with you. He would say it like this child needs more remediation before they start school. They need to have more experiences, more training, whatever it was that they were lacking. So all of this was simply to figure out which kids were ready to start right now and which kids needed to wait some amount of time before they entered the school system, and presumably got some experience in that meantime. Then the intelligence testing movement came to the U.S. We're a little more competitive in the U.S. apparently than the French were back then, and so when Louis Terman at Stanford University got a hold of the Binet test, he revised it into what is now known as the Stanford Binet. And don't worry, it's been revised a bunch of times. We're not still using a 100-year-old test and calling it the Stanford Binet. The big difference between Terman and Binet was that Terman thought that intelligence was genetic, that we inherited our intellectual capacity and that no amount of experience would move you significantly from one level of intelligence to another. He developed a concept that a phrase that you've used, IQ. That's short for intelligence quotient. The average intelligence score, the average IQ, was set at 100, and a nice little ratio was constructed to establish whether you were average or above or below average. So there's that word mental age that we got from Binet. So we've got your mental age, which is basically your score on the test, right? So you scored like a 4-year-old or you scored like a 5-year-old. And then we've got your chronological age, the actual age that you are. So you're a 5-year-old. So let's say that you scored like a 4-year-old, but you are a 5-year-old. So it's going to be 4 over 5 in that ratio. If we divide that out, it comes out to 0.8. Then we multiply it by 100, and we end up with a score of 80. So we would say that that person is below average, right? Because average is 100. So that person's below average. So IQ is supposed to be calculated based on this ratio of mental age to chronological age. And then you multiply it out by 100 to get rid of the decimal point. If your mental age and chronological age match, then of course you're going to end up with a 1 over 1, right? So let's say your mental age is 5, you score like a 5-year-old, that's 5 over 5, that's a 1. So obviously you're average, you're performing exactly as you should for your age. Okay. Now the thing that's really important to recognize about Binet is that he thought, why are we only testing children with this? Just think, there are so many applications for a test such as this in industry, in the military, in government, things like that. So he not only revised Binet's test for children, but he extended it and made questions that were too hard for children to answer. So we wouldn't expect the kids to get these right, but that would extend up into what we would expect adults to know. And so Terman pretty quickly, after revising Binet's test and reworking it, made it into something that could be administered to incoming recruits in the military or an employment candidate or other kinds of situations like that for adults. Let's see, what else do I want to tell you about Terman? He was quite the interesting character. Like I said, the Stanford Binet has been revised a bunch of times, and so it is still today the most commonly used intelligence test, but it just went through a big revision about, I guess it was probably 8 years ago now, and they reworked all the questions to make sure that they were not antiquated or out of date. Like when the Binet test was initially translated by Terman, one of the things he had to do was get rid of things that you wouldn't expect Americans to know, but that you would expect French to know, like when is Bastille Day, or they literally asked 5-year-olds questions about wine because apparently it's general knowledge. So they took that stuff out for the American population. So they took some of the French stuff out and, of course, translated it in English. And then with each revision, they've tried to keep up with the times with regard to the kinds of questions that are on the test. So, for example, one of the test questions back in its early developmental stages asked about there was a question that was something like, what does taking a bath and going to the movies have in common? And it's one of those conceptual level questions where you're supposed to think about the relationships between things. And they pulled this question out of the test because it was no longer relevant, because the answer was Saturday night. Because apparently back when they first constructed the question, people took baths on Saturday nights and then went to the movies on Saturday nights. So they're like, well, that would be the thing that ties these two concepts together, right? Well, modern respondents are just completely flummoxed by that question. They're like, sitting down? I don't know. Like, I have no idea. So those kinds of things over time are weeded out so that it's current for the modern, sample that's taking the test. So no longer do you get asked questions about tennis and other kinds of things that aren't necessarily universals. And that could be seen as kind of classist or ethnically, biased. So what they've tried to do in modern tests of the Stanford Binet is to make sure that the questions represent general knowledge, not things that are more likely to be known by some people than by other people. They try and make sure it's sex balanced and stuff like that too. And then they test it out on groups of people that represent the entire variety of American population. When they first developed it, they let their Stanford University students serve as the norming data, the group that would take it and show you what an average score looks like. Now they realize that's very biased, and so now they have the sex balance that's appropriate for the U.S., the racial breakdowns that are appropriate for the U.S. They have all the demographics represented. So now we know that the Stanford Binet is actually a fair test for anyone to take, from 2 to no top limit. I would really strongly advise you that no intelligence test, no matter what they say, is reliable until we're testing older kids. Minimum age 8. Really, most stability really appears by age 16. So be really careful about scores that were obtained from younger groups. All right, now let's talk a little bit about what intelligence is. Okay. Sternberg says intelligence is made up of 3 components, so he calls it his triarchy. One component of intelligence is analytical, solving a well-defined problem with a single answer. This is the kind of intelligence that's measured by the Stanford Binet. They ask very well-defined problems, and there is a right answer. So that's analytical intelligence. Practical intelligence is expertise and talent that help to complete the tasks and manage the complex challenges of everyday life. You might call this common sense, practical intelligence. And people who are really high in analytical intelligence and not as high in common sense, right? I mean, you do not, in Sternberg's model, have to be high in all of the intelligences or low in all of them. You can be high in some and low in others. Creative intelligence is, the ability to generate new ideas to help adapt to novel situations. So creativity is thought to be independent of the other two. And so you can be highly creative and then not necessarily very good at solving well-defined problems, and vice versa. In fact, researchers have found that there is a correlation, a positive correlation between intelligence and creativity. Up till the person's IQ is about 120, and then there starts to be a negative correlation, typically, between analytic intelligence and creativity. And that's actually a really good, that makes a lot of sense, because analytic intelligence involves finding a single answer to the question, whereas creativity asks you to do virtually the opposite of that, right? Take a single cue and generate lots of different responses possibly, right? Like, tell me all the things you could do with a paperclip. Well, if you're going to come up with creative responses, you're going to have to think outside the box. You're going to have to come up with lots of different ideas, right? So a person who's really good at finding the single correct answer, it might interfere with their ability to generate lots of novel solutions that are not necessarily part of the correct answer, right? So not only are these things independent, but they in some ways might kind of run against each other. So Sternberg thinks that there are these 3 kinds of intelligence, and he's actually making a really strong argument. He's still alive, and he's a researcher today. He's making a really strong argument that instead of taking SAT, which is sort of content-based, that we should give incoming college students a test that would assess these 3 parts of intelligence to make sure that they are going to be able to cope well at college, which would be the practical intelligence component, do well in their classes, that's the analytic intelligence, and then creative intelligence, be able to, maybe advance thinking and help, to improve theories and stuff like that. So he's trying to make an argument that we should use this kind of intelligence test instead of a SAT. Okay, so that was 3 components of intelligence. How about what if we had 8? Technically, Gardner is up to 9, but that's just starting to get too much. So I'm going to stop at 8. I think we'll make our point with 8. So Howard Gardner suggests that we have 8 different and independent components to intelligent behavior. There's linguistic intelligence, our ability to speak, to write in ways that allow other people to understand. There's logical mathematical, solving mathematical problems, thinking very logically in an orderly way, using those algorithms that I was talking about earlier in this chapter. There's musical intelligence, which would be your ability to produce, to appreciate music. So even if you're not a musician, if you've got rhythm and you can recognize tonality and stuff like that. There's spatial intelligence. This picture shows her creating art, which is part of a spatial intelligence, but spatial intelligence also includes things like knowing where the chess pieces are on the board if you know how to play chess, being able to navigate through space, driving around town, stuff like that. That awareness of where north is, that kind of thing. There's bodily kinesthetic, knowing where your body is in space, and so dancing and athletic ability would fall under that category. Intrapersonal, this picture is very misleading because intrapersonal is being aware of your own states, your own motives, being able to soothe yourself when you're upset. So it's within. Intra means within, so it's all the stuff within yourself, your own handling of yourself, as far as like your emotionality and stuff. Interpersonal, that's between people. Inter means between. So now this is your ability to read other people's emotions. This is your ability to relate to other people, to empathize, things like that. And then we've got naturalist as our last one here. So understanding your role in the ecosystem, your impact on the environment, things like that. Okay, so he's got 8 independent intelligences. And he literally thinks that these are housed in different parts of the brain. He's not exactly sure where any of them would be. But one thing that he points to as evidence that they are independent is autistic savants, people who have autism and savant skills. And to be a savant means that you're doing something like amazing, either mathematically, musically, or spatially. And usually to be diagnosed with autism, you would have interpersonal and intrapersonal deficits. So when you see a person who has difficulty, making eye contact and soothing themselves when they're upset and things like that, but they can hear a musical piece played once and then they can play it themselves. Or there's an autistic savant man who he can do one flyover in a helicopter of a city, and then he'll spend the next several months drawing this gigantic mural of the city from memory. No pictures or anything, just from memory. Those kinds of skills. Howard Gardner points to those kinds of people and says, see, if you have a deficit in one area, it'll allow the other areas to shine. It's kind of hard to test that claim, but there's a researcher up at the University of British Columbia who figured out a way to do it. He uses this magnetic stimulation device to sort of stun areas of the brain, and he's found that if he stuns parts of the limbic system, he can get temporary savant skills like mathematical capabilities and spatial skills out of his participants. Unfortunately, it gives them a really bad headache, so most people say it's not worth it to have that temporary savant experience, but it kind of suggests that Gardner may be onto something, at least with those, interpersonal, intrapersonal, and then the logical, mathematical, musical, and spatial being sort of maybe opponent processes that if one's dampened, the others might shine more. But it's really hard to test some of the claims that he's made. You may be familiar with this theory inadvertently from school, because a lot of teachers have been using the idea that if you have a natural ability, like let's say that you're really good at sports, maybe you don't really like to read, maybe I can use sports things that come naturally to you to engage you in reading so that you'll be willing to move forward on that. So you might have encountered this in your educational background as teachers have tried to use these principles to engage you. All right. It's a good time to define some words. So we have the word aptitude and we have the word achievement. When we're talking about intelligence, sometimes you'll hear people talking about aptitudes, and sometimes you'll hear people talking about achievement-based intelligence. So what are we talking about? Achievement tests are most of our intelligence tests, and they usually are going to be testing what you already know. So we'll ask you math questions or language questions or when is Independence Day questions. Aptitude tests, on the other hand, measure your ability to acquire a new skill. So SAT used to stand for Scholastic Aptitude Test. That used to be what those letters meant. And what they were claiming is that your SAT score before entering college would correlate with your grades once you were in college. Like it would predict your ability to acquire the information that you're going to encounter in college. It turns out that there aren't very good correlations between SAT and college grades, in part because a lot of colleges don't take people whose their SAT scores are below a certain number. And so there's no way those SAT scores could predict grades because there's not enough variation in SAT scores among the college population. So it's kind of an impossible question to answer anyway. But what does correlate really well with SAT score is IQ score. It turns out that achievement-based IQ scores correlate really well with aptitude-based SAT scores. SAT has finally acknowledged this, and they stopped calling it the Scholastic Aptitude Test. They call it the Scholastic Assessment Test. And part of the reason why they gave in is they recognized that people were studying for the SAT. And how could you study for an aptitude? Your ability to learn a new skill. How would you study for that? So you shouldn't be able to study for an aptitude test. But the fact that people could study for SAT, they finally changed it at least somewhat. I would like them to call it the Scholastic Achievement Test. That's what I would like to see, just honesty and disclosure. Now, some of you might have taken a really good aptitude test called the ASVAB, or Armed Services Vocational Aptitude Battery. That test does a really good job of predicting your ability to acquire the skills that they would teach you in the military, like mechanics or apparently I scored really well in the radar screen operating section that I don't even know what, because the Marine Corps wanted me to come do it. Yeah, that would have been funny. I would have been kicked out so bad. But that test is really well designed to pick up the cues that a person has that indicate that they might be good at some skill that's available in the military. Now, it correlates really well with IQ also, but you can't study for the ASVAB. Like, it's impossible to study for. So it's probably a little bit more aptitude-ish, but it is definitely tied to IQ. So, but you know what? IQ is tied to almost everything that has to do with, performing well on things anyway. So it's a very tricky thing to talk about. All right, I'm going to show you some items from a particular test. This is called the Wechsler test. These are actually items off of the child's scale it's not one that's used anymore, but I just thought I'd show you the kinds of questions they ask. I like the child's test so we can feel like we're succeeding. So there are two main subtests in the Wechsler test. There's the verbal subtest and the performance subtest. The verbal test asks for linguistic answers to questions. So, for example, the general information question, what day of the year is Independence Day? Now, of course, there's a right answer that they want to hear, which is the 4th of July, but other countries gained independence from their colonizer, and they got independence on not the 4th of July. So they may give a correct answer, but it's not the correct answer in the Wechsler test. So there's a little bit of, clearly this is for Americans to take this test. Similarities. In what way are wool and cotton alike? And so you would want to explain their fibers. They're fluffy. They're often white. They can be woven. Things like that. They're breathable. They're natural. Arithmetic, vocabulary, comprehension. All of those are good examples of it already sounds kind of verbal, but this next one doesn't sound verbal. But the thing is, you're going to be answering using verbal descriptions. So that's why it's part of the verbal test. The digit span, this is a memory test. And so the test administrator reads off the digits. The respondent says those digits back in the same order that they heard them. In the second part, the administrator reads the numbers in that order, and then the participant's supposed to say them in reverse order. So it's a really difficult memory test. Then we get to the performance part, and this is going to be, a lot of times people will call this the nonverbal part, because you don't even have to be able to speak to give answers. So, for example, they show you a calendar, and you're supposed to say what's missing. I swear, I hunted all through that calendar the first time I saw this. I'm like, I can't find anything missing, and what's missing is the month. But I'm like, didn't even see that. Picture arrangement, you're supposed to arrange these pictures to tell a story. Again, you can make an argument that this is clearly for American respondents, because if you're from a part of the world that doesn't have any snow and you see, this creature that's done at the end, and then the kid running away, maybe he's running from the creature, not running out to it, you can imagine you might organize the pictures in a different order based on your experiences in the world. So yeah, this is clearly for American audiences. Block design, you see the 4 blocks on the diagram. The child on the right is being given that kind of test. So you see the 2-dimensional thing that you're supposed to be making, and then you're given these 3-dimensional blocks that can rotate and have different patterns on them, and you're supposed to organize them into the picture. That's a test that can be used to diagnose people with Alzheimer's, because they'll have a great deal of difficulty figuring out the pattern. The next one is putting a puzzle together, and then the last one is digit symbol substitution. So you're given the little code, so a triangle equals 1, so you're supposed to put a 1 in the box underneath all the triangles and so on. Something that's really important, you'll notice the test administrator in this photograph has a stopwatch. All of these tests are timed, and part of your score is based on how quickly you completed the test. Okay, so how do we make tests? This is true for the construction of intelligence tests, but it's also how we attempt to make exams in classes too. Standardization, I mentioned this when I described how Binet did the test of mental age. Standardization is when we interpret an individual's score by comparing it to the performance of others who have taken the test before. So, like I said with Binet, he had a group of 4-year-olds, a group of 5-year-olds, a group of 6-year-olds. So now when you come take the test as a 5-year-old and you get a particular score, I'm going to compare your score to the average for the different age groups and figure out what age group you score like. So with standardization, we're going to not just look at your raw score and draw inferences about you. We're going to look at how you scored compared to other people. All standardized tests have that component to it. Now, not all tests in classes are standardized. We don't always have a group of people who take the test first and show us what a good score looks like. Usually we make up new tests for each quarter, and we just hope that it's a decently constructed test. So this is one area where classroom tests usually aren't standardized. Now, with standardization, we are able to develop a normal curve and figure out what average scores should be and what standard deviations are. So a normal curve is a statistical, sort of a static thing. It applies to all sorts of different kinds of qualities. Most personality characteristics are normally distributed. Most biological measurements, heights and weights and shoe sizes and things like that, are normally distributed in populations. So the normal curve applies to lots of things. This isn't just an intelligence testing issue. So what we have found is intelligence seems to be normally distributed in the population. All IQ tests are now scored with 100 being the average score. So no matter how many items are on the test or anything else, average score is going to be 100. That way, your score on the Wechsler test could be directly compared to your score on the Stanford-Binet or on the Woodcock-Johnson or whatever IQ test you take that's a standardized test. So everybody has the 100 as the average. Now, in normal curves, it is always just a fact that 68% of people will fall within one standard deviation of the mean. So our mean is 100. One standard deviation goes down to 85 and goes up to 115. So 68% of the population have IQs that fall between 85 and 115. Go one more standard deviation out, and we're going to include 95% of the population within 2 standard deviations of the mean. So 95% of the population have IQs that score between 70 and 130. So 85 to 115 is considered average. 1 standard deviation below that is called below average. 1 standard deviation above that is called above average. So below average, above average, that encompasses 95% of the population. A very small number of people fall above 130 or below 70. Unfortunately for us Americans, more is always better, and we think that, 100 would be a bad score, but that's considered normal. That means that you're functioning on all cylinders. That's where you're supposed to be. If you're between 85 and 115, that's considered normal. One more step out, you're above average or you're below average. One more step out, you have hardly anyone out in those areas. So 2% of the population have a score, 2.1 have a score that's above 130, and 0.1% of the population is 145 or above. And same thing on the other end. Very few people are below average, right? So only 2.1% of people fall below the below average categorization. So normally distributed scores. And standardization allows us to know that things are normally distributed. Okay, now reliability gets at the issue of whether this test can generate consistent results, especially for an individual. So with the Stanford-Binet, for example, they say you can take it when you're as young as 2, and you can take it, any time for the rest of your life. It's appropriate for you to take the Stanford-Binet. The least reliable scores are the ones that are obtained from people who are less than 8 years old. So testing very young kids can be dicey. But if you were 8 or older when you were tested, more than likely, no matter when you got tested again, you would get virtually the same score again. Most intelligence tests are highly reliable. You tend to get the same score within just a few points every time you take the test. Now, there are a couple of caveats. I'm going to show you this again. So the average score is 100. And if you're a child, when you take an IQ test, if you're less than 18 years old, your score is still computed using that mental age divided by chronological age. So let's say that you're 8 years old when you take an IQ test and you score like an average 16-year-old. You're going to end up with an IQ of 200. You'll notice 200 isn't on our normal curve, right? That's well outside the capabilities of the points available on the test. Even if you do it the fastest possible time, there's no way for you to score 200. The highest you can get is a 160. That's all the points there are. So if you took the test when you were 8, you scored like a 16-year-old, you're told you have an IQ of 200. If you took the test again as an adult, you would score maximum 160. And then you'd think, oh my gosh, I've dropped 40 IQ points. This is terrible. But the thing is, you haven't dropped 40 IQ points. What's happened is you've reached the max on the adult test. Because we don't calculate it in the way that you do for a child, the max you can get is 160. So I usually recommend to people, if you scored really high when you were a kid, don't take the test again, because you're going to regress towards the mean, because the test is limited. It's all it can do. So it's not very reliable for people who scored well outside of the average range. But if you fell within the normal distribution as a child, you're probably going to fall in basically the same spot if you took it again as an adult, as long as you were at least 8 years old when you took it. Now, I don't know about you guys, but I changed the clock in my car to be a little early so that I'll kind of, I don't know what I think that's going to do, make me not dawdle or something. I don't know why I do it. But what I've created is kind of a math test. I look at my clock in my car and I go, okay, I know it's 2 minutes ahead, so it's really what time, right? It's reliably the wrong time every single time I look at it. So it's reliable, It's always time plus 2. No, time minus 2. Time plus 2? Yeah, time plus 2. Yeah. I don't even know what the math problem is. Actually, maybe this works fine. I don't know. Every time I look at it, it's time plus 2. It's reliable. It's consistent. It produces the same outcome every single time. But is it valid? And that is the question that really dogs intelligence. It's like that clock that's been set incorrectly. It may be producing the same result every time, but is it really measuring what it's supposed to measure? I know my clock isn't, because my clock is supposed to be measuring time. It's not supposed to be measuring time plus 2. Is it possible that we think we're testing intelligence and we're really testing something else? That's our problem. So what is intelligence? Okay, be forewarned. The correct answer is I don't know, but I'm going to tell you some theories, because we haven't really even today agreed on what intelligence is. That should have been maybe clear to you when I gave you 3 different theories I gave you 2 clear ones. The idea that there are 3 kinds of intelligence, the idea that there are 8 kinds of intelligence. Underlying that was the idea that intelligence is just one thing. And actually there's a theory that says there's 120 different kinds of intelligence. So clearly we have not agreed on what is intelligence. We haven't even decided, how much intelligences are there. We haven't agreed. So I'm going to say we don't know. I'm going to give you both sides of each of these questions. So first off, is intelligence culturally defined? Okay. Some people say yes, that your culture determines what it's going to call intelligence. So whatever your culture deems important will be labeled intelligence. So in American culture apparently and Western European culture, they've decided that intelligence is facility with the language and math skills. And so that's what we include our intelligence tests. We point to hunter-gatherer culture in Africa that apparently has an intelligence test that includes taking the young warriors before they go on their first big hunt, and they administer an intelligence test, which involves them putting their hand into a nest of biting ants. And the one who comes out with the fewest bites on him is deemed the most intelligent in his group. Seems arbitrary, but if you think about it, if you're going out on your first hunt and you live in a place that has nests of biting ants, maybe, figuring out a way to get them off at the least damage to yourself would be a sign of intelligence, right? So the fact that different cultures have such widely disparate definitions implies that intelligence must not be a stable thing that's consistent across cultures. People who take this perspective say that it would be impossible to ever come up with one test that you could administer all over the world that would always assess intelligence, that it's always the case that culture would impact your scores. Now, the no side of this argument says IQ is just a basic set of problem-solving skills. It might manifest itself as common sense, or it might manifest itself as creativity, but it's still the same basic thing. It might manifest itself as doing well on a math and language test, or it might manifest itself as figuring out a way to get ants off of you without getting very many bites. But it's still the same basic, problem-solving capability that's underlying both of those things. These guys point out that here in the U.S., if we really valued the things that our intelligence tests measure, our most successful people, which in the U.S. we oftentimes measure with status or income or both, our most successful people would be the ones who scored the highest on intelligence tests, because those are the things we value, that we deemed important. But, the highest paid people in our culture are not necessarily the ones with the highest IQs. So the fact that IQ and job success are at almost a zero level of intelligence, of correlation, makes us realize, well, clearly you can make up a test that contains things that we don't actually value enough to pay for, right? Obviously. So is it culturally defined? Maybe. Is it inherited? The yes side of the argument says, yes, and I can prove it by looking at twins. So please only look at the part that I've put into a frame because it will undermine the yes side of the argument. So just look at the framed part. If we look at identical twins who were reared apart, remember back when we talked about this in Chapter 2, we talked about how some twins back in the 30s and 40s had been separated at birth and adopted out to different households, and they got reunited in the 80s. The identical twins who were reared apart had IQ scores that matched more often, were more correlated than fraternal twins who are reared together. Remember, identical twins share 100% of their genes, and fraternal twins share only 50%. So when we see that identical twins, even when they didn't share the same environment, are more similar to each other than fraternal twins who did share the same environment, we make the argument that, well, see, genes obviously play a big role in intelligence. We can also look at adopted children. When we look at, okay, this is kind of a complicated graph. So first off, the teal bars are children correlated with their parents, their biological parents, who also raised them. So the teal blue bars are kids who were raised by their biological parents. The red bars are kids who were adopted by another family and are being raised by another family, but we're making a correlation between the kids and their biological parents' intelligence scores. And then the blue bars are those same adopted children, but now we're correlating them with their adoptive parents. So what we see with adopted kids is that when you're 3 years old, it looks like maybe only kids who are being raised by their birth parents, there's a little bit of a correlation between them. But for the adopted kids, there's no correlation between their intelligence and then either their adopted or their biological parents. But at 16, now we see that the kids and their birth parents, whether they're being raised by them, which is the teal bar, or not, which is the red bar, they score much more like their biological parents than the adopted children score like their adoptive parents. That's at, I don't think you can get any closer to zero than that. So biology by age 16 seems to be playing a much larger role than environment. The adopted parents are not having much influence on their adopted kids' intelligence. So we look at twins and we see that those who share more genes in common are more like each other, whether they were reared together or not. And we see that from looking at it from the opposite side, that biology seems to win out more by age 16 than environment does. Okay, but now let's zoom out on that picture that I tried to get you to only look at the framed part last time. And let's take the no side of the argument. So we're back on twins. So notice that the far left bar is identical twins who were reared together. And you see that if you know the IQ score of one of the twins, you will about 85% of the time be right if you just guess that the other twin has that same score. Now we take a step down from that. If we look at identical twins who are reared apart, which is the next bar, that's only 70% of the time I'm going to be right if I guess that they have the same score. Now we get to the fraternal twins reared together. Now the first two bars, they have the same amount of genes in common. Now we're taking a step down with genetic overlap, and we see that we drop almost the same amount as we did with the identical twins when we reduced the amount of environmental sharing, right? So it looks to me, if you walk down these stair steps, that if we change the amount of genes in common, we lose the same amount of predictability as we get when we change how much environment they have in common. Siblings reared together come next, and we see that they are not as similar as fraternal twins. And one of the things you have to remember is that fraternal twins are just regular siblings that shared a womb. So they had that similar environment prior to birth for that first 9 months of life. And then they also have that tendency, they were the same age as they're going through life. And people have that tendency to call them the twins and treat them similarly and invite them to the same stuff. And they go to the same camps because they're the same age. Their parents are just funneling them through the same things. So fraternal twins' experiences are more similar than regular siblings are. And then we have unrelated individuals reared together, and they, have less overlap in their IQ scores. So the no argument points out that environment plays a role, right? When we see the lower correlation between identical twins reared apart than we see with the identical twins reared together, we say, wow, see, environment does play a role. So is it inherited? What we've come to say, and this is going to sound probably kind of like weak, is something between about 60 and 75% of intelligence is probably due to genes. It's a pretty wide range, somewhere between 60 and 75%. Pretty wide range, but they think about that amount could be attributed to genes, and then the rest of it is going to be due to environmental experiences. So clearly the environment plays some role. This one, again, we're going to have to say maybe, but not because we don't know, but more because we're like, well, there's strong arguments on both parts. I think it's really clear from this twin research that it's almost the same amount contributed by genes as contributed by environment. Now, I wanted to point out some issues that have to do with environment. A lot of times we think about how we can improve somebody's intelligence scores. It's really hard to boost a person's intelligence score above what it would naturally do with just a normal healthy diet, normal interactions with the world, stuff like that. Intelligence doesn't, it's almost like you go to your top spot pretty easily, and it's really difficult to like boost a person past that top ability. What's much, unfortunately, easier to do is to undermine their maximum capacity. Neglect can do that for children if they don't have adequate diet, if they don't have adequate interaction with the world, if they aren't talked to often enough, if they aren't shown enough variety of things as they're developing. Those kinds of neglectful experiences can undermine intelligence. Enrichment doesn't really seem to have that kind of effect on the top end that neglect has on the bottom end of intelligence. Okay. Here's an illustration of, let's assume that seed packet, all the seeds came from the same mom plant. So they all have the same genetic material in it. And some of them are placed into poor soil, we'll call that the neglect. Some are placed into the enriched soil, we'll call that the enriched. You have a bunch of flowers that look pretty normal on the fertile soil. Some didn't do as well as others. There's variation within that group, but on average, the fertile soil looks like they achieved their full potential. The poor soil, you see some that did relatively decently, did better than their peers, and some that were really significantly harmed by being in that poor soil. Think about intelligence like that it's, lacking proper nutrition, exposure, and things like that could do to a child what being in the poor soil would do to the seeds. So you'll notice this slide is labeled group differences. Historically, there have been numerical differences in the average scores for different groups. When you look at racial groups, on average, Asian Americans score higher than white Americans, who score higher than Hispanic Americans, who score higher than Black Americans, on average. One really important thing to note is variation within groups, right? That different people perform differently even though they belong to the same group. So we can never assume anything about any individual who belongs to a group, because they could be doing better, they could be doing average, they could be doing worse than other members of the group, than the average of their group. So we never know how an individual is going to perform just because we know they belong to a particular group. But some research has shown, looking across all around the world, that any group that is in a disadvantaged position within the culture tends to score more poorly on tests of intelligence within that culture. So whenever you're looking at group differences, and a lot of people have really highlighted these racial differences in the U.S., when you look at these differences, it's important to keep in mind that intelligence is influenced by negative outcomes more profoundly than it is by positive outcomes. So, good things don't necessarily push these flowers to be, twice as tall as they were designed to be. That doesn't happen, right? They tend to just reach their fullest potential when they're in fertile soil. But you can stunt their growth. You can stunt development when there is, poor soil, inadequate support, things like that. The other group differences I wanted to talk about was male versus female differences. And again, there are group differences, but we can't say anything about an individual just because we know that they belong to a group. So keep that in mind. There's a lot of variation within the groups. But there are two cognitive abilities that males and females tend to score differently on. Males tend to do better on mental rotation tests. So what you see in a mental rotation test is the standard on the left, and then you're supposed to say which, if any, of the responses on the right are that standard rotated. Males tend to be faster at this task on average than females. Not all males, not all females, but on average, right? So if your brain is frying while you're trying to figure it out, I'll mark the two that are, in fact, the standard rotated some amount. One big difference between males and females is females tend to be slower at this task, and a lot of times when you ask females to describe what they were thinking about while they were solving the problem, they actually say something. They say, well, I was thinking, well, that one it's mostly flat, but it has that one sticky outy thing, so I was looking for the other ones with the sticky outy things. Whereas if you ask a male what he was thinking about when he was doing it, he'll say, well, I don't know, nothing. A lot of times they don't have a verbal response for that, yet they got the answer right. And so one hypothesis is that females are more likely to have their language skills interfere while they're trying to complete a spatial task, and it slows them down. And so one of the things that I mentioned earlier is that most intelligence tests are timed. And so when you can do it faster, you get more, IQ points, towards your total score. Now, females tend to really excel at linguistic tasks on average. So typically, we find that the average female score would be higher for a task like this where you're supposed to unscramble the words. And some of these are a little bit easier to unscramble. Others that kind of already look like words that really make you struggle. But on average, females will do this faster. And then they can take the circled words and create the correct word more readily. Again, in case your brain's frying, I'll just go ahead and give you the answers. So we do see on average group differences where males excel in the spatial side and females excel on the linguistic side, but please don't forget, individual variation within groups oftentimes is larger than the difference between groups. So keep that in mind whenever we talk about group differences. All right, that concludes intelligence. So thank you guys for listening. I'll see you in the next chapter.